Imagine for a second that you're standing in the middle of a massive, bustling city. There are thousands of cars moving through intersections, skyscrapers being constructed, electricity flowing through underground grids, and millions of people trying to get to work without bumping into each other. Now imagine there are no traffic lights, no police, no city planners, and no maps. That absolute chaos is exactly what your computer hardware would be without an operating system. Your CPU, your RAM, and your hard drive are just expensive piles of silicon and metal until a piece of software steps in to act as the ultimate conductor. Today, we are pulling back the curtain on the digital ghosts that run our world. We are going from the very first punched cards to the neon-soaked future of cloud computing. This is every major operating system explained in detail. To understand where we are, we have to go back to the beginning, before Windows, before mice, and before even the concept of a screen. In the 1940s and 50s, the earliest computers didn't really have an operating system. If you wanted to run a program, you were the operating system. You had to manually set switches, plug in patch cables, and load stacks of paper-punched cards into a reader. The computer would execute exactly one task at a time and then sit there, doing nothing, until you manually cleared the memory and loaded the next job. This was incredibly inefficient because the human was the bottleneck. While the person was fumbling with paper cards, the million-dollar computer was wasting precious seconds. This led to the birth of the first real step toward an OS, the batch processing system. Instead of a human standing over the machine, a small piece of resident software sat in the memory. It would wait for a batch of jobs to be loaded, and as soon as one finished, the resident monitor would automatically trigger the next one. This was the first time software took over the management of hardware. It was basic, it was rigid, but it proved that a computer could manage its own time. But the real revolution happened in the late 1960s and early 70s with the birth of Multics and, eventually, Unix. Before Unix, every single computer model had its own unique language. If you wrote a program for an IBM machine, it wouldn't work on a DAC machine. It was a digital Tower of Babel. A group of brilliant engineers at Bell Labs, names like Ken Thompson and Dennis Ritchie, decided they wanted something different. They created Unix. The magic of Unix was its simplicity and its portability. It used a hierarchical file system, which is why we have folders inside folders today. It also introduced the concept of pipes, allowing the output of one program to become the input of another. Most importantly, Unix was written in the C programming language, which meant it could be ported to almost any hardware. If the modern digital world has a DNA, it's Unix. Your Mac, your iPhone, the servers running the internet, and even your smart fridge are likely descendants of this one project from the 70s. Now, while Unix was ruling the massive mainframes in universities and labs, something else was happening in the garages of California. The era of the personal computer was dawning. In the late 70s, a company called Digital Research released CP/M, or Control Program for Microcomputers. For a few years, this was the king of the early home computer world. But then came the legendary deal that changed history. IBM was building their first PC, and they needed an operating system. They famously approached Bill Gates and his tiny startup called Microsoft. The twist? Microsoft didn't actually have an OS to sell. They quickly bought a Unix-like clone called QDOS, Quick and Dirty Operating System, from another company, tweaked it, and renamed it MS-DOS. MS-DOS was a text-based, command-line world. There were no icons. You had to type DR to see your files and CD to move between directories. It was clunky, but it was reliable. Because IBM was the gold standard for business, MS-DOS became the default language of the office. Microsoft was smart. Though they didn't just sell it to IBM, they kept the rights to sell it to other companies, making IBM-compatible clones. This decision effectively paved the way for Windows to dominate the planet. But while Microsoft was conquering the office, another vision was brewing at Apple. Steve Jobs had visited Xerox PARC and seen something that blew his mind: the Graphical User Interface, or GUI. Instead of typing cryptic commands, you could see a desktop with files and use a mouse to click on them. In 1984, Apple released the Macintosh. It was the first mass-market computer to ditch the command line for a visual experience. It felt like magic. It made computers accessible to artists, writers, and students who didn't want to learn computer science just to write a letter. Microsoft saw the writing on the wall. They released Windows 1.0 shortly after. But let's be honest, Early Windows wasn't really its own operating system. It was just a skin that ran on top of MS-DOS. It was slow and prone to crashing. It wasn't until Windows 3.1 and specifically Windows 95 that Microsoft truly stepped into the modern era. Windows 95 was a cultural phenomenon. It introduced the Start button, the taskbar, and plug and play, making it possible to connect a printer without a 3-hour struggle with configuration files. By the late 90s, the war was seemingly over. Microsoft won the desktop, Apple was struggling to survive, and Unix was reserved for the high-end server closets. However, a quiet revolution was starting in Helsinki, Finland. A student named Linus Torvalds was frustrated with the high cost of Unix licenses. He decided to write his own kernel, the core part of an OS that talks to the hardware. He called it Linux, but instead of keeping it a secret or trying to sell it, he released the source code to the public for free. He invited everyone to help him build it. This was the birth of open source. Thousands of developers around the world began contributing code. Today, Linux is the most widely used operating system in the world, even if you don't see it on your laptop. It runs the top 500 fastest supercomputers. It runs the vast majority of the cloud. It runs the Android operating system on your phone. Because it is modular, you can take the Linux kernel and build whatever you want on top of it. These different versions are called distributions or distros. You have Ubuntu for beginners, Fedora for developers, and Arch Linux for the brave souls who want to build their system from the ground up, piece by piece. Linux proved that a community-driven project could compete with, and often outperform, the biggest corporations on Earth. Let's move back to Apple, because their comeback story is legendary. In the late 90s, Apple was months away from running out of money. They brought Steve Jobs back, and he brought with him an operating system called NextStep, which was built on Unix. This became the foundation for macOS 10. It combined the beauty and ease of use of the Apple interface with the rock-solid stability and power of Unix. This is why many developers and creatives love Macs today. It's the best of both worlds. A gorgeous front end with a professional-grade command line underneath. This same foundation was later slimmed down and optimized to create iOS, the operating system that launched the smartphone revolution in 2007. Now we have to talk about the other mobile giant, Android. While iOS is a closed system, meaning only Apple makes the hardware and controls every pixel of the software, Google took a different approach. They bought a small startup called Android and built the OS on top of the Linux kernel. They made it open so that any hardware manufacturer like Samsung, LG, or Google itself could use it. This led to a massive variety of devices at every price point imaginable. Android is a masterclass in flexibility. It manages your battery, your touchscreen, your cellular signal, and millions of apps, all while running on hardware that range from $50 budget phones to $2,000 folding devices. But what about the things we don't usually think of as computers? This takes us into the world of RTOS, or real-time operating systems. If your PC crashes and shows a blue screen, it's annoying. You lose some work and you restart. But if the computer controlling an airplane's wings or a hospital's heart monitor crashes, it's a tragedy. Standard operating systems like Windows or Mac are general purpose. They try to do many things at once and occasionally take a moment to think or run a background update. And RTOS is different. It is designed to be deterministic, meaning it is guaranteed to respond to an event within a precise, microscopic window of time. Systems like QNX or VxWorks are what actually run our critical infrastructure. They are invisible, they are incredibly simple compared to Windows, and they are built to never ever fail. Speaking of specialized systems, we have to mention Chrome OS. Google realized that for many people, the operating system is really just a way to get to a web browser. So they built a stripped-down OS based on Linux that essentially just runs the Google Chrome browser. All your files are in the cloud, and all your apps are web-based. This made laptops, Chromebooks, incredibly cheap, fast to boot, and easy to manage. It redefined the idea of what an OS needs to be. For a student or a causal browser, you don't need a massive, heavy OS like Windows. You just need a window to the internet. Now let's look under the hood. Every single one of these systems has to manage the same 4 things. First is process management. Your CPU can only do a few things at once. The OS acts like a high-speed traffic cop, giving each app a tiny slice of time, sometimes just milliseconds, before switching to the next one. It happens so fast that it looks like everything is running at the same time. This is called multitasking. Second is memory management. Every app needs space in your RAM. If one app leaks and takes more than its share, the whole system slows down. The OS creates a sandbox for each app, making sure they don't step on each other's toes. If you run out of RAM, the OS uses a clever trick called virtual memory, where it temporarily swaps data onto your hard drive to keep things moving. Third is the file system. Think of your hard drive as a massive, empty warehouse. The OS comes in and builds the shelves, the bins, and the indexing system. It keeps track of where every single piece of data is stored, who is allowed to see it, and when it was last changed, whether it's NTFS on Windows, APFS on Mac, or ext4 on Linux. A file system is the invisible librarian of your digital life. Fourth is device management. Your computer is connected to dozens of different pieces of hardware: keyboards, webcams, GPUs, and printers. Each of these speaks its own language. The OS uses drivers to act as a translator. When you press a key, the keyboard sends a raw electrical signal. The driver translates that into a character, and the OS sends that character to the app you're currently using. As we look toward the future, the traditional definition of an operating system is starting to blur. We are moving into the era of the hypervisor. Instead of one OS running on your hardware, a hypervisor allows you to run multiple virtual machines at the same time. You could have a Windows machine for gaming and a Linux machine for work running on the same physical box. This is how the modern internet works. When you visit a website, it's likely running on a container or a virtual machine in a massive server farm, sharing hardware with thousands of other websites. We are also seeing the rise of edge operating systems. These are tiny, specialized systems for the Internet of Things, your smart light bulbs, your thermostats, and your security cameras. These systems have to be incredibly power efficient, often running on tiny batteries for years, and they have to prioritize security to prevent your home from being part of a botnet. Then there's the concept of distributing the OS itself. Some visionaries believe that in the future, your OS won't live on your device at all. Your phone or laptop will just be a thin client, or a terminal, and the actual processing and management will happen in a decentralized cloud. Your desktop follows you from your phone to your car to your office, always synced, always ready, regardless of the hardware you're holding. However, with all this progress comes a significant challenge: security. In the beginning, OS security was barely an afterthought because computers weren't connected to each other. Today, every OS is a target. Modern systems like Windows 11 and macOS Sequoia use hardware-level encryption and secure enclaves to protect your biometrics and passwords. The battle between the OS designers and the people trying to find loopholes is a constant, 24-hour-a-day cycle. This is why you get those annoying updates. They're not just for new features. They're the OS designer patching a tiny crack in the city walls before anyone can climb through. Let's pause and appreciate the sheer scale of what an operating system does. Every time you move your mouse, the OS is calculating the coordinates, redrawing the screen at 60 to 120 times per second, checking to see if you clicked on anything, managing the power usage of the sensory light, and ensuring no other program interrupted that movement. All while you aren't even thinking about it. It is the most complex thing humans have ever built, with millions of lines of code working in perfect harmony. The history of operating systems is really a history of human intuition. It's about how we've moved from speaking the machine's language of ones and zeros to making the machine speak our language of windows, icons, and voice commands. We went from the rigid, cold environment of MS-DOS to the fluid, beautiful animations of modern smartphones. We went from a world where one person could understand the entire system to a world where it takes thousands of engineers just to maintain the kernel. Whether you're a gamer who swears by the performance of Windows, a developer who lives in the terminal of Linux, or a creative who loves the flow of a Mac, you're participating in a legacy that stretches back to the very first vacuum tubes. The OS is the bridge between the physical world of electricity and the abstract world of human thought. It is the silent partner in every email you send, every game you play, and every video you watch. As we move forward, the OS will likely become even more invisible. Artificial intelligence is already being integrated into the core of Windows and macOS, predicting what you want to do before you do it, automating your boring tasks, and organizing your files better than you ever could. The desktop metaphor that has served us since the 80s might eventually fade away, replaced by augmented reality interfaces or even direct neural links. But whatever form it takes, the soul of the machine will still be there. The operating system, managing the chaos, and making the digital world a place where we can actually live and work. So next time your computer asks you to restart for an update, or you see the spinning wheel for a split second, give a little nod to the invisible conductor. There is a massive XXXXXX complex and beautiful city of logic working deep inside your device, making sure that when you click, something actually happens. Behind every pixel and every byte, the operating system is there, keeping the lights on in the digital age. Thank you for joining us on this deep dive into the architecture of our modern lives. The more we understand the code that surrounds us, the more we can appreciate the incredible ingenuity that makes our high-tech world possible. Keep exploring, keep learning about the machines that power your dreams, and we will see you in the next one as we continue to unlock the secrets of the digital frontier.